Hey everybody, this is Mr. Beckstrom, and today I'm doing an example from section 6.4, and it says find the exact value of the sine of 2 theta given that the sine of theta is equal to negative 15 over 17 and theta is in quadrant 3. Alright, so in order to do this one we need to delve into the double angle identities. And for that, we can go to page 518, and I'll just kind of write out what this identity says. So it says that the sine of 2x, so 2 times the angle, is equal to 2 times sine of x times cosine of x. Alright, so that means that if we want to find the exact value of the sine of 2 times an angle, we can also do that by taking 2 times the sine of that angle times the cosine of that angle. Well, we know sine of x, they give it to us, or sine of theta in this case, but we don't know what cosine of theta is, so we'd have to actually find that out before we plug it in there. There's a couple of different ways we can do that. We know the Pythagorean identity, sine squared of theta plus cosine squared of theta is equal to 1, and since we have the sine of theta here, we'd only have one unknown, so we could solve it that way. I don't like doing that. You all know I like triangles, so I'm going to set me up a triangle here and solve it that way. We know we're in the third quadrant here, so if I just set up my angle in the third quadrant, I make my triangle using the closest x-axis, which happens to be the negative x-axis here, so that I make my right triangle that way. We always use the angle originating from the origin, so that is my theta, and the sine is opposite over hypotenuse, so 15 is the opposite, and the 17 is the hypotenuse. So we need to solve for this side here. So that is going to be, well, we know 17 squared minus 15 squared, right? So let me pull up my calculator here. So this is on my hypotenuse. So 17 squared minus 15 squared is 64, so this is actually going to be the square root of that, which is going to be 8. Is that right? So this side is 8, and let's just double check, make sure that works. So 8 squared plus 15 squared, enter. Does that equal 17 squared? Sure enough, it does. So this is an 8, 15, 17. I forgot that was a known triangle there. It's been a little while for that one. All right, well that's nice. So we're not dealing with any square roots then. So that means that the cosine of theta, is equal to, and we know it's going to be negative because we are in the third quadrant, is adjacent over hypotenuse, right? So that's going to be negative 8 over 17. Once again, we also could have used the Pythagorean identity, but I like to always set up triangles. And if you set up the triangle, you can easily get all 6 trig functions by doing that. So now we can go back over here, and we can say the sine of 2x is equal to 2 times the sine of theta, which is negative 15 over 17, times the cosine of theta, which is equal to negative 8 over 17, which is equal to, the negatives will cancel out, so the top will be 2 times 15 times 8, which is 240. 2 times 15 times 8, which is 240. So 240. And the bottom will be 17 squared. 17 up 17. So 17 squared, which is 289. 289. I don't think that that reduces. Let me see. 240 divided by 289. Sometimes it will reduce it for you. Let's see if it does it in here. Nope, that's in reduced form right there. So that is our final answer. All right. If anybody has any questions, please let me know, and I hope you have a great rest of your week. Thanks.